Alright, so section 5-8. We will be looking at radical equations and inequalities. So we're going to actually solve radical equations, equations with radicals, and equations with inequalities. So anytime we have an equation with a radical, whether it's an inequality or not, you have to check the answer. So we did a little bit of this before. So this should be a repeat. So do this one on your own. X plus 1 plus 2 outside the radical equals 4. So this was from, what, 11-3? So do that one on your own. What do you have to remember to do? Subtract that 2. So you have to get the radical on one side by itself first, then you can square both sides. Make sure you check it, and you have to show the check. Share your answer with those around you. Okay, so what did you get? 3. Does the answer work? What's your check? What equals what? 4 equals 4. If you're missing any lines on that check, you're not checking correctly. So remember, your check is like a mini proof. More is better. Because you're proving to me that it works. You're not just checking it for your own benefit, you're proving it to me too. Alright, so example 2, something slightly more difficult than what you had before. Is that good? Solve. So this time we have the square root of x minus 15 equals 3 minus the square root of x. Oh, we haven't had that before though, right? So this one's kind of new. You have two radicals. Sometimes you might have to square both sides twice. It depends on what happens. So your goal is to get one radical on one side by itself. This is the more complicated radical, so that's the one that I would make sure was on one side by itself first, because when I square this, that complicated radical is going to go away. When I square this, however, the radical is not going to go away, because remember, this is 3 minus the square root of x times 3 minus the square root of x. So when we square the left, we're going to get just x minus 15, right? But when we square the right, we have to double distribute or FOIL. So 3 times 3 is 9. 3 times the negative square root of x is what? Negative 3 square root of x. And then I have to distribute the negative radical x. So multiply that to the 3, I get another negative 3 radical x. And then I multiply those two together. A negative times a negative is a positive. What's rad x times rad x? Just x. So then combine your like terms. So these are alike. We've got x minus 15 equals 9. What's a negative 3 rad x and a negative 3 rad x? Negative 6 radical x and then plus x. So now what do you think we should do? We have a radical in the problem, so I want to get the term that has that radical, which is this whole term right here, on one side by itself. Doesn't matter what side. So I'm going to get rid of this x and that 9. So subtract an x, a nice thing occurs that both x's cancel out. and then we're going to subtract a 9 and subtract a 9. And so I'm left with a negative 24 on the left equals negative 6 radical x. Do I have my radical by itself yet? No. So continue, I've got to divide by a negative 6. And so I get a positive 4 equals the square root of x. Now what do you think we do? Square both sides again. So we get, I'm going to flip this around, we get x is equal to 16. That was a bit of a longer process. So we're going to check that. So let's check it in the original problem. So I'm going to put 16 in where the x should be. 16 minus 15 is 1, so I've got the square root of 1 equals 3 minus, what's the square root of 16? 4. What's the square root of 1? 1. A lot of you forget that that's part of the square. What's 3 minus 4? Negative 1. Does that check? No. So what's my answer? No solution. Sometimes we're going to get an answer, sometimes we won't. All right, so example 3. So we will solve. This time you've got 3 parentheses, 5n minus 1, n parentheses, raised to the 1/3, yay, minus 2 equals 0. What do you think I should do? What does that 5n minus 1 to the 1/3 really mean? Isn't it a cube root? Don't I technically have a cube root, or instead of the parentheses, wouldn't I have a cube root here? So if I have a root, what do I want to do with a root? To solve a problem. Get it on one side by itself, right? So I need to get just the parentheses here, just this part on one side alone. So how do I start? Add the 2. So now I have 3 parentheses 5n minus 1. That raised to the 1/3 equals a positive 2. Is it by itself yet? Nope. It's being multiplied to this, so I need to divide. And so now I get 5n minus 1 to the 1/3 equals 2/3. I can't square both sides, right? Because if I square both sides, I put a 2 here, that's a power to power. 2 times 1/3 is 2/3. So what do I really have to do? Whatever that denominator is, that's what you want to raise both sides to. Since the denominator is a 3, I'm going to cube both sides because 1/3 times 3 is 1. And my whole goal is to get that denominator to cancel out. What I do to one side, I have to do to the other side. So power to power, this right there becomes 1. So I end up with 5n minus 1 equals, I have to raise the numerator to the 3rd power and the denominator to the 3rd power. So 2 to the 3rd is 8, 3 to the 3rd is 27. Then to solve for n, I'm going to add 1 here, but when I add 1 here, I don't want to add 1. I want to add something over 27 because I want like denominators that is equivalent to 1. So what would that be? 27. So I end up with 5n is equal to 8 plus 27 is 35 over 27. Does that reduce at all? What goes into 35? 5 and 7. There's 5 or 7 going here. No. So then here I'm going to divide by 5, but I don't want to divide this by 5. I want to multiply by what? 1/5. Dividing by 5 and multiplying by 1/5 are exactly the same thing. So the 5's here cancel. and I get n equals, this time the 5 here will cancel with that 35 7 times, and so I end up with 7 over 27. Not a pretty answer, but an answer nonetheless. Do I know if that's a correct answer? No. And you're not going to like the check, but you are going to have to check it because it might not work. So here goes our check. So this is a fraction 7 over 21. So I'm going to put the 5 over 1. Oh, 27. And then minus 1 raised to the 1/3 minus 2 equals 0. Now we're not going to move anything right or left because we're checking. So the right side should always remain 0. So let's do what we can do here. We've got 3 times, nothing cancels, so 5 times 7 is 35 over 27 minus, again I want to make that 1 into something over 27. So wouldn't it be 27 over 27 raised to the 1/3 minus 2. 3 times, what's 35 minus 27? 8 over 27 raised to the 1/3 minus 2 equals 0. Then 3 times, this is really asking that I take the cube root of this, but in order for you to see what we're really doing, I'm going to change 8 to its prime factored form and 27 to its prime factored form. So 8 prime factored is 2 to the 3rd, 27 prime factored is 3 to the 3rd, raised to the 1/3 minus 2 equals 0. What happens when I raise a power to power? I'm multiplying, the 3's will cancel. So don't I end up with here, the 3's here will cancel and I get a 2. And then I have to multiply the 3 to the 1/3 also. So these 3's will cancel and I get a 3. Minus 2, bless you, equals 0. This is a fraction being multiplied to a number, so I'm going to put that over 1. The 3's cancel. I end up with 2 minus 2 equals 0. Does 0 equal 0? Check. So be patient with your check. Don't force the check to work because it's highly possible it's not going to work. So 7/27 is a good solution. All right, then let's look at example 4. Now we're going to get into inequalities, and inequalities become a real pain in the derriere, which is your rear end. So we're going to solve, and we've got 2 plus the square root of 4x minus 4 is less than or equal to 6. So we have 2 issues going on here. We have an inequality, which is an issue in and of itself, and the square root. So we've got 3 things that we must do. So we have to find restrictions on the radical itself. And I'm going to be a little lenient with this because you're kind of brand new to this. The very first thing you have to do is find the restrictions. On the radical. What do I mean by find the restrictions on the radical? What does that radical have to turn out to be? We can only take the square root of what kind of numbers? Can I take the square root of a negative number? No. Can I take the square root of 0? What's the square root of 0? 0. So I can take the square root of 0, I can take the square root of a positive number, I just can't take the square root of a negative number. So this value, 4x minus 4, has to come out to be greater than or equal to 0. If it doesn't, we're going to have an issue. So you're going to set it greater than or equal to 0. Just what's under the radical. So we're going to ignore the radical and just take that value, 4x minus 4, and set that value greater than or equal to 0. Because I'm finding those restrictions. So solve for x. Add a 4, I get 4x greater than or equal to 4. Divide by 4. X is greater than or equal to 1. So my x must be greater than or equal to 1 so far. Then step B, we're going to need some room, so B, put it up here. You're going to solve the whole inequality, the whole enchilada. So we're going to take 2 plus the square root of 4x minus 4 is less than or equal to 6. So again, our goal is to get the radical by itself. So what are we going to do first? What are we going to do? Subtract 2. So I get the square root of 4x minus 4 is less than or equal to 4 because I subtracted 2. And now what do? You still square both sides. So I get a 4x minus 4 is less than or equal to 16. Now solve, add 4. 4x is less than or equal to 20, divide by 4. X is less than or equal to 5. When you're dealing with inequalities, what causes you to flip an inequality sign? Multiplying or dividing both sides by a negative. Not subtracting both sides, not multiplying or dividing to a negative, but multiplying or dividing by a negative. Okay, that's the only time that you're going to flip that sign. Or if I flip the x and the 5, then I would also flip the sign. Alright, so we're going to check our solution. That means that x has to be greater than or equal to 1, or x has to be less than or equal to 5. Is that an or an and? Greater than 1, less than or equal to 5. Isn't 1 less than 5? So 1 is to the left of 5. So if this is a less than, I'd have an arrow going this way, and if this is a greater than, I'd have an arrow going this way. So if my arrows look like this, is that an and or an or statement? And statement. So let's check our solution. So that's your last part, C. Check your solution. So we're going to graph it. So where's my little ruler? I'm going to graph it over here. And I only need my boundary points, which are 1 and 5, on my graph. So according to this, greater than or equal to 1, I would have a closed circle at 1 because it's equal to, and an arrow going to the right. Less than or equal to 5, I would have a closed circle at 5 because of the equals to, and an arrow going to the left. And so they meet in the middle. So remember, when we've done this before, you have to check to the left of your boundary points, in the middle of your boundary points, and to the right of your boundary points to see that it holds true. So I need, I should get false here, 2 trues here, and at least a false there. You might get a true and a false and a true and a false, but in order for it to be and, it has to be 2 trues for the line to be there. So we're going to check, easy checks. So to the left, what's an easy number to check? 0. So I'd be checking 0. So we're going to check it in the original problem. So what's 4 times 0? 0. Minus 4? Can I take the square root of negative 4? No. So because I can't take the square root of negative 4, this is false. The minute I get 1 false, we're done. There should be nothing over there. So no, it makes sense that there's no line. What are you going to check in between here? What are you going to check? 2, 2, 3, 4. It doesn't really matter, right? I'm going to check 3 because it's further away from this I can write. So if I put 3 in here, what's 3 times 4? 12. 12 minus 4. Oh, I'd rather check 2. Wouldn't you? Why would you rather check 2? Because it'll give us a perfect square. So if we check 2, what's 2 times 4? 8. What's 8 minus 4? 4. What's the square root of 4? 2. What's 2 plus 2? 4. So I have 4 is less than or equal to 6. Is that true or false? True. So it makes sense that the line is there. So I'm going to adjust my check to make it easier on myself. Then out here, what would be an easy number to check that's going to give us a nice little perfect square, possibly? 6. No. Yeah, 10. So let's choose 10 way out here somewhere. So 10 times 4 is 40. What's 40 minus 4? 36. Square root of 36? 6. What's 6 plus 2? Is 8 less than or equal to 6? True or false? False. So our solution is good, and therefore our solution is, and you can write your solution 2 different ways. We've talked about interval notation, set builder notation. Either way is fine. We've also talked about sandwiching. So let's just talk about interval notation since it's new and we seem to struggle with it. What's your left bound? 1. And isn't it an equals to? What's your right bound? 5. And isn't it an equals to? So that would be your interval notation. It kind of looks like an ordered pair because it's an and statement, but it's not. If I were to do set builder notation, you could do x such that x is greater than or equal to 1 and x is less than or equal to 5. Or you could sandwich it. If you sandwiched it, you wouldn't have this x here. You would have x such that, if we put x in the middle, 5 would be on the right, and you'd have to flip the sign because we're switching this around, flipping the 1 on the x, and so you'd have a less than sign there. So then you could do x such that, you could do that as well. So you have 3 different choices. All right, last problem. So example 5. Solve. So we have the square root of 2x plus 3 minus 4 outside the square root less than or equal to 5. So first, we want to find what? Yeah, so find the restrictions. On the radical. Set it greater than or equal to 0. So just what's under the radical, so that 2x plus 3 is greater than or equal to 0, so solve. So far we have x being greater than or equal to negative 3 halves, right? Which is negative 1.5. Then b, actually solve the whole inequality. So you go and solve it on your own. So we get a fairly large number. X is less than or equal to 39. And then we have x is greater than or equal to negative 3 halves. So this is left of this one. So again, it looks like an and statement. So step 3, or C, you check your solution. So a false means there's no line. A true, you should have a line. So on this one, since we have such a huge difference in numbers, we're going to estimate our line. We'll put 0 here and 39 here, and then we'll just say that this is negative 3/2. So I should have a closed circle at both of those and a line in between. So then let's check. Let's check to the left. I'm going to choose a number to the left that the 2 is going to divide out of, or at least, and so I don't want to check, I don't really want to check a fraction. So what can I multiply out here that will give me a nice little perfect square? Well, what's going to happen, first of all? If I choose, let's just say I choose negative 2, because it's the first whole number to the left of negative 3/2, right? Well, it's not a whole number, first integer, right? So what's negative 2 times 2? Negative 4 plus 3. When I get a negative square root, I'm going to get a negative 1 here. Am I going to be able to take the square root of negative 1? So this is going to be false, just like it was in the previous problem. So if you get a negative under that radical, which is part of the restrictions, then we're not going to be able to have a solution there. So I can stop there. I don't really have to compare left and right side. In here, if I choose 0 this time, will I be able to take the square root of 3? No. So what should I maybe choose? What? I can't hear you. 3? So if you do 3 times 2, it's what? 6 plus 3 is 9, so that'll work. So let's just say we're checking 3 over here. So what's the square root of 9? 3. What's 3 minus 4? So we have 1. Is that less than or equal to 5? True or false? True. So that works. What do you want to check to the right? That'll give us a perfect square. Because if I choose 40, 40 times 2 is 80. I'm now at 83. We just missed 81, the perfect square. What can I multiply it by? Could we estimate a square root if you can't think of it right away? Sure. So let's go ahead and use 40. So if we do 40 times 2, we get 80. 80 plus 3 is what? 83. So 83, the square root of 83 is between the square root of 81 and what? Square root of 81 and what? 100. So it's somewhere between, the square root of 81 is 9, the square root of 100 is 10. So for chuckle's sake, we're just going to estimate it right in the middle. So can't we say that that square root is 9.5? What's 9.5 minus 4? Isn't it 5.5? Is that less than or equal to 5? True or false? That's false. So it makes sense that there'd be no line here. So again, our solution is good. And so how are you going to write your solution? You've got to encompass both of these. How are you going to write your solution? There's set builder notation with it sandwiched, or set builder notation without a sandwich, but you better use the word and. Or what's interval notation look like? Left bound, right bound. A bracket at -3/2 and a bracket at 39. So any of those three are good answers. So really, your new issues have been, what do you do if you have a square root on both sides or 2 square roots? You end up having to square twice. Do check your answer, because you will not always come up with a good solution. And then with the inequalities, this is new, where you have to find the restrictions on the radical as well as solve the whole inequality, and then you have to check that. these two happen to work out, but you'll find on your homework that they don't. I've purposely given you odds tonight. Why do you think? It's going to take you some time. So you only have about 12 problems to do. So that's a good thing.